So it's a very logically easy topic and very limited concepts are there which are repeated in the exams. Okay. So we'll just cover the basic, very important things. And today I'll be solving some previous year questions also. So let's see how it goes. Okay. Okay. So first of all, suppose we take a semiconductor like a silicon or germanium. Suppose we take a block of silicon. Okay. So silicon can be doped in two ways. It can be doped in two ways. Either you can add beryllium, beryllium नहीं क्या होता है, boron. ठीक है, basically we can make it p type or n type. ये दो चीज होते हैं. So now silicon by itself, it has four valence electrons, right? And in its crystal structure, it is all the electrons are occupied. ठीक है. So silicon has a crystal structure, and it's all the four valence electrons are occupied in valence bonds, in a covalent bonds. Now p-type means what? You introduce a atom in replacing silicon, which has only three valence electrons, like boron. So you're replacing the silicon with boron. ठीक है. So you're replacing this silicon with boron, and due to this, one hole is created here. Hole means there is no bond with boron because boron with any valence electrons. So that is why a hole is created like this. So this is called a p-type impurity, and yeah. Similarly, n-type impurities क्या होता है? Replacing silicon, instead of silicon, what you add? You add, suppose you add phosphorus. So phosphorus has five valence electrons. So in the crystal structure, it will have four bonds plus an extra electron. Okay. So that is this is called an n-type impurity. क्या समझ में आ रहा है ना सबको? It is clear वैसे?
Yes.
ठीक है.
सर वो एन टाइप थोड़ा बोल सकते हैं?
If you see silicon is a silicon का जो solid होगा, ऐसे कुछ होगा. ठीक है. Now what you are doing, you are replacing silicon with another atom. Suppose यहाँ पे silicon की जगह आपने boron को add कर दिया. So boron, because it has three valence electrons, so तीन covalent bond ही बनेगा इसका. और यहाँ पे एक hole बन जाएगा. ठीक है.
सर
हाँ बोलिए मैं.
सर यहाँ पर आप डोपिंग कर रहे हैं?
हाँ डोपिंग कर रहे हैं. ठीक है. And in place of silicon, if you add phosphorus, तो phosphorus में चार bonds बनेंगे प्लस एक एक्स्ट्रा इलेक्ट्रॉन रहेगा बिकॉज phosphorus has फाइव वैलेंस इलेक्ट्रॉन्स. ठीक है. तो इसको हम लोग एन टाइप बोलते हैं. इज इट क्लियर अंशु?
Yes, sir.
Okay. So now first of all, we take a solid in which on one side we dope it with, we make it p type. एक साइड हमने उसको p टाइप बना दिया और एक साइड में उसको n टाइप बना दिया. Okay. So making it p type means it will have lots of holes. ऐसे कुछ होगा. Okay. And on the right side we have n type. So n type means that it will have lots of electrons. Also means majority charge carriers will be electrons. ऐसे कुछ होगा. थोड़ा बड़ा हो गया. Okay. So you take a silicon crystal in which you are doping it with p type. You take another silicon crystal which is doped with n type, which is made n type, and then you fuse it. Actually, initially I disconnected. So both are independent crystals like this. Okay. And now then you fuse. दोनों को जोड़ देता है. ठीक है. So जोड़ने से क्या हो जाएगा basically? If you fuse them, so what will happen? Here we have majority charge carrier the electrons. They are unbonded. Right? So due to this, these electrons will go here and they'll start filling these holes. Okay. So after some time, scenario कुछ ऐसे हो जाएगा. So यहाँ पे electrons गायब हो जाएंगे and यहाँ से holes गायब हो जाएंगे. ठीक है. But now because electrons will be removed, so यहाँ पे net charge positive रह जाएगा and यहाँ पे net charge negative हो जाएगा because electrons are added here. So this terminal will become negative. यहाँ पे positive charge accumulate हो गया. Okay. तो इसी डायग्राम को अगर आप थोड़ा और एक्सटेंड करते हैं, so it will do something like this. ठीक है. Now these electrons which are there, they also want to come and merge with the holes which are present here, right? But now there's an electric field which will be opposing the flow of electrons. So electrons also want to flow like this, but there will be an electric field from positive to negative. So this electric field will oppose the flow of electrons. Okay. So that is after some time what happens? A barrier is formed. इसको हम लोग barrier बोलते हैं. So barrier like this is formed. So there is a positive terminal, there is a negative terminal. Okay. So this is called the potential barrier. So क्या बोलते हैं हम लोग? We call it depletion layer also. या potential barrier बोलते हैं. ठीक है. And this depletion layer has some potential difference associated with it, which is called the height of potential barrier. ठीक है. So if you carefully see, there is a dynamic equilibrium here. That means there is no net flow of charges. कोई charges flow नहीं होंगे यहाँ पे. So here this majority charge carriers which are electrons here, they will not flow. Neither the holes will flow. ठीक है. Now there are minority charge carriers which will flow. Minority charge carriers will flow. but in equal amounts. So because they are flowing in equal amounts, that is why there is no net charge. कोई net charge flow नहीं करेगा circuit में. ठीक है. So ये हो गया मेरा dynamic equilibrium. Now one more important thing here is the electric field here, which is delta V by delta X. This will be very high. So that is why no majority charge carriers can flow through this potential barrier. Okay. ऐसा है. Is this clear everyone? यहाँ तक clear है सबका?
सर वो डेल एच क्या है सॉरी डेल वी
Del V is this height of potential drop, height of potential barrier. कुछ potential difference है क्या दोनों points के बीच में? वो potential difference ही del V है. ठीक है. Okay, बाकी लोग clear है? Is this clear? रूपसा, ओलिविया, आयुषी?
Yes, sir.
Yes.
Okay. So now let us see the characteristic of this semiconductor. So if you plot current versus voltage, this is very interesting. So, so now if you increase this voltage, so it is observed that current also increases little bit. And after a particular value, it jumps. ऐसा होता है. ठीक है. So in this case, the diode can be shown like this. ये diode को हम लोग ऐसे दिखा सकते हैं. Basically इसको diode बोलते हैं. This is P type and this is N type N. So this is called PN junction diode. PN junction diode. Okay. So now if you connect this P type to a positive terminal, so इसको forward bias बोलते हैं. And इसी का ग्राफ में भी बना रहा हूँ. So as you increase this voltage, so current also increases slowly. And what happens at a particular value of voltage? So basically क्या होता है जब आप P type को positive terminal connect करेंगे, so slowly this barrier decreases in size. जो हमारा barrier है potential barrier ये वाला, this size decrease होता है because the external voltage is opposing this uh, potential barrier. So slowly as you increase the voltage, this barrier decreases, and it will decrease till the point वो potential difference zero हो जाता है. And as soon as the potential difference becomes zero, so the ये voltage पे, that time what happens? Then suddenly current starts to flow very high because the barrier को हटा दिया आपने. So it is observed that the current increases drastically like this. Okay.
Sir, can you repeat?
See, here there is a potential barrier, right? And you are supplying an external supply of voltage. ठीक है. So ये barrier हमारा ऐसे कुछ है. And you are supplying an external battery. ठीक है. So now as you increase the external voltage, this will oppose the potential barrier already present. ठीक है. And as you increase the external voltage, तो वो opposition को कम करेगा. कम क्यों करते हैं basically यहाँ पे क्या होगा? These basically the electric field will be opposed by the external electric field. ये बैटरी का जो electric field है, सो आप इसको इंक्रीज करेंगे, इंक्रीज करेंगे, इंक्रीज करेंगे, सो दिस इलेक्ट्रिक फील्ड विल बी रिड्यूस एंड फाइनली जीरो हो जाएगा, आफ्टर विच करंट इंक्रीजेस वेरी मच। अभी समझ में आया वैष्णवी?
Yes, sir.
सर
हाँ बोलिए।
सर डायोड का मतलब?
डायोड का मतलब क्या है? ये डायोड है ना, एक पी टाइप है, एक एन टाइप है, दो पोलैरिटीज है तो डायोड बोलते हैं उसको, ठीक है।
Sir,
हाँ बोलिए।
sir, here you told that we'll increase the potential to such a level that the internal potential will become zero. मतलब यहाँ पे potential सच में zero होता है या we give energy like kinetic energy to the electron so that it can pass through that
हाँ या
potential.
पोटेंशियल बैरियर जीरो हो जाएगा ना, जो भी यहाँ पे देखो, यहाँ पे जो इलेक्ट्रॉन्स प्रेजेंट है दे विल अगेन स्टार्ट टू गो हियर, ठीक है। So as you increase this potential barrier, like external voltage जब increase करेंगे, so more and more electrons will flow, and ये जो बैंड गैप है पोटेंशियल बैरियर छोटा हो जाएगा, ठीक है।
Sir, you said that electrons will flow.
हम्म,
मतलब वो कैसे होगा? How will electrons flow? But there are holes.
अरे भाई होल्स नहीं है ना यहाँ पे, पहले इलेक्ट्रॉन्स है ना। सी जब हमने डायोड को बनाया था, सो इलेक्ट्रॉन्स फ्लो किए
सर
थे नहीं
आपका
ऐसे।
आवाज नहीं आ रहा।
एक मिनट नाउ इज इट ओके?
Yes, sir.
सी when the diode was made, so electrons came from here and they merged with the holes, right? तो यहाँ पे नेगेटिव चार्ज हो गया, पॉजिटिव चार्ज हो गया, इनिशियली ऐसे हुआ था ना।
Yes, sir.
So now when you're applying the battery, they'll force the electrons to again go back here, जो बाहर से बैटरी लगा रहा है, ठीक है। सो एज स्लोली द इलेक्ट्रॉन्स गो, तो धीरे धीरे ये पोटेंशियल बैरियर कम होगा, बिकॉज जो चार्जेस है इनिशियली दे आर सेपरेटेड, नेगेटिव एंड पॉजिटिव, देन अगेन वो चार्ज कम होते जाएगा, कम होते जाएगा, एंड फाइनली इट विल बिकम जीरो। ओके,
Yes, sir.
ऐसा है। सो ये था हमारा, या सो आफ्टर पर्टिकुलर वोल्टेज दिस इज कॉल्ड नी वोल्टेज जनरली बोलते हैं इसका, या बीसी बोलते हैं। So after this the current increases very much, ठीक है। So here the voltage actually it is in millivolts and the current is in milliamperes, okay। And this condition is called forward bias, ठीक है। Now if you do reverse bias condition, तो रिवर्स बायस में क्या होगा, बेसिकली जो हमारा डायोड है इसको आप उल्टा कर देंगे। सो you'll the p end you'll connect it to negative terminal and जो n वाला end है you'll connect it to positive terminal, तो उल्टा कनेक्शन कर दिया हमने इसको, ठीक है। सो इसमें क्या होता है, सो यहाँ पे तो ऑब्वियसली करंट को ज़्यादा, करंट विल बी वेरी लेस, even if you increase this voltage करंट बहुत कम होगा, बिकॉज पोटेंशियल बैरियर को आप इंक्रीज कर रहे हैं, तो ऑब्वियसली करंट कम होता है, so it is very less, very less, very less, ठीक है। सो हियर व्हाट हैपेंस, दिस बैरियर स्टार्ट्स टू इंक्रीज, ये जो हमारा बैरियर है धीरे धीरे इंक्रीज करेगा, इंक्रीज करेगा, इंक्रीज करेगा, ठीक है। so as this barrier increases again करंट बहुत कम होगा, and like barrier increases and it will increase so much that it will become to the size of the diode only। तो जो हमारा बैरियर है इतना बड़ा हो जाता है, इनिशियली इतना था, फाइनली इतना हो जाता है, ओके। And then if you further increase the voltage, so that potential barrier becomes, it exceeds the size of the diode only, and अगर ऐसा होगा तो क्या होगा, so obviously this is called breakdown, so the diode breaks actually, and then due to which again suddenly the voltage increases, sorry current increases, बिकॉज हमारा डायोड ब्रेक हो जाता है, यहाँ पे जलने का भी डर हो सकता है, ठीक है। So this particular voltage, this is called breakdown voltage. So we said that the diode breaks down at this particular voltage. Okay. Now here the voltage is in very much. It is only in volts. जो हमारा voltage है यहाँ पे, and the current will also be less. It will be in milliamperes, microamperes. ठीक है. So here the current is in milliamperes. यहाँ पे microampere में होगा. यहाँ voltage millivolts में, and reverse bias के लिए it will be in volts. Okay. So these are the two states in which we use the diode. Now some important things we should know, like here the current is very less, it is in microamperes, because here the minority charge carriers, they carry the charge. अब बोलेंगे minority कैसे, minority कहाँ से आ गया? So basically either the electrons can take the charge or holes can take the charge. ठीक है. So अगर if it is n type, so there will be more electrons. So electrons will be majority charge carriers and holes will be minority. अगर n type है तो p type है तो क्या होगा, उसमें holes थोड़ा ज़्यादा होगा, electrons थोड़ा कम होगा. So holes will be majority charge carriers and electrons will be minority. ठीक है. So in this case the minority charge carriers, they carry the current, तो इसलिए current थोड़ा कम होता है. And this depends on the temperature. ये बहुत important है. So as soon as you increase the temperature, so this current will increase because the minority charge carriers, they will produce more in number. Okay. And in the case of forward biasing, so here the majority charge carriers, they carry the current. So यहाँ पे इसलिए current बहुत ज़्यादा होता है. And और क्या होता है? Yeah. And this depends on the doping. ये doping पे depend करता है, temperature पे depend नहीं करता. So if the doping is high, then current ज़्यादा हो जाएगा. Doping कम है तो current कम होगा. And this depends on temperature, not on doping. Okay. तो ये सब थोड़ा important चीज़ें था. इनका रेशियो भी बोल सकते हैं. This will be 1:100. इस रेशियो में रहेगा. Okay. And also forward bias में क्या होता है? Basically forward bias means in this potential barrier this decreases and delta x also decreases. And reverse bias में क्या होता है? The potential barrier also increases and length of the barrier also increases. Reverse bias में. ठीक है? ऐसा है. Okay. कई जगह है क्या? ठीक है, आप एक और चीज लिख लेते हैं. Now if you see this, so generally use semiconductors is silicons and germanium. Silicon and germanium को use करते हैं. So इनका band energy gap and इनका knee voltage. This is 0.7 volts. So this is 0.7 volts होगा. This will be 0.3 volts. EG कितना है इसका? This is 1.1 electron volts. This is 0.7 electron volts. Okay. So generally silicon is used because it is little safer. Silicon को use करते हैं. Okay. Hopefully आपको ये पता है EG क्या होता है? Between the conduction band and valence band, जो में energy का difference होगा, that is EG. ये आपने solid state में पढ़ा होगा chemistry में. ठीक है. So ये हो गया हमारा. चलो. यहाँ तक clear है सबको? Is this clear everyone?
Sir,
Yeah, बोलिए.
so can you tell why silicon better?
What?
Why is silicon better? It has knee voltage which is less, then that is more useful. No?
It has knee voltage which is more. It
You
is
written 0.7 and 0.3.
several.
0.7 and 0.3.
No. देखो ऐसे कुछ है. ठीक है. Now is it clear? For silicon it is 0.7. For germanium it is 0.3.
So then we have to provide a minimum voltage of 0.7 to get push current through the diode.
Yeah. For silicon.
And we have to give a minimum current of minimum voltage of 0.3 volts to push the current through germanium.
Yeah.
So then giving 0.3 is less and 0.7 is more.
But see, the diode is used for many times it is used as a switch. So for switching, it is better to have little more potential difference. Like switch में क्या होता है? Either it is on or it is off. ठीक है?
Sorry, you're not audible.
So generally it is used as a switch. So in switch what happens? जो हमारा potential difference होता है, suppose there is a diode like this. उल्टा हो गया क्या? ठीक है? So if we increase this voltage, so after 0.7 volts, if it is silicon, then it will start to conduct, right? And before 0.7 volt, it will not conduct. Okay. So now this variation in voltage, if it is little more, then silicon will be better instead of germanium. ठीक है. अगर suppose AC voltage है हमारा, ठीक है, and this is like it varies from 0.4 to minus 0.4. So if you use germanium here, the germanium will turn on, but silicon will not turn on. And 0.4 volts is very less. So like germanium थोड़ा ज़्यादा ही sensitive हो जाता है in that case. Silicon is little less sensitive. ठीक है. So that is why we use silicon in general. समझ में आया वैष्णवी? This is one of the reasons और भी है.
Yes.
Okay. कहाँ थे हम लोग फिर? बाकी लोगों को समझ में आया? Is this clear? रोशी, ओलिविया, मयूक, clear अच्छा? Okay. So this is about PN junction diodes. बहुत important है. Now second is we define a property called as mobility of electrons and holes. So basically mobility means this is velocity of electron per unit electric field. So mobility of electron is defined as the velocity divided by E. कौन सा velocity use करते हैं हम लोग? Yeah, drift velocity. So this is the mobility of electron. Okay. Now it is a known fact that mobility of electron is greater than mobility of holes. That means electrons and holes are not identical. Electrons are little better charge carriers than holes. Okay. Now, if you take for any conductor, कोई भी conductor के लिए देखेंगे, so we can define current in the conductor as current carried due to collect like electrons plus current carried due to holes. Okay. And current को आप लिख सकते हैं V by R. And इसको क्या लिख सकते हैं? N E VE into A plus NHE into VH into A. ये हमने करंट इलेक्ट्रिसिटी में पढ़ा था, होपफुली याद होगा. सो V को आप क्या लिख सकते हैं? इसको लिख सकते हैं E into L डिवाइडेड बाय R को लिख सकते हैं रो L बाई A. दिस इज EA into एल से एल कैंसिल हो जाएगा, ए से ए भी कैंसिल हो जाएगा. सो यू गेट 1 बाय रो इक्वल्स टू
सर
E इंटू बोले NH इंटू VH बाई E. हाँ बोलिए ना.
Sir, can you let me in? I'm joining through another device. This is having some internet issue.
अच्छा, सो ऐसा है. सो 1 बाय रो इज इक्वल टू दिस मच. सो 1 बाय रो इज नोन एज कंडक्टिविटी. सो दिस इज E इंटू म्यू E N E, sorry, E इंटू म्यू इंटू N E plus mu H into NH. This is the conductivity of a semiconductor. Very very important relationship. ठीक है. So
सर
for any conductor,
वो सर
हाँ बोलिए.
सर वो आई एच किसके लिए है वो?
Current carried by the holes,
ओके.
and this current carried by the electrons. ठीक है. हमने पढ़ा था करंट में J इक्वल टू एन वी डी होता है, करंट डेंसिटी. सो वही फॉर्मूला यहाँ पे लगाया हमने. ठीक है. याद है, क्लियर है सब लोगों को? कोई डाउट इसमें? यस, इज क्लियर? ओलिविया, रुप्सा,
Yes, sir.
मयूक,
ठीक है,
क्लियर? अच्छा,
मोटामोटी.
ओके चलो. So now let us do some questions. Question time आता है.